Welcome in online lecture of TY.BSc CH-333. We are studying reactions of unsaturated hydrocarbons and carbon-oxygen double bond. In the previous lecture, we have studied the hydrogenation reactions, that is addition of hydrogen across carbon-carbon double bond. Now, last and important reaction of the addition reaction of carbon-carbon double bond that we have to study is the ozonolysis reaction. Ozonolysis reaction. Now, in ozonolysis reaction, addition of ozone across carbon-carbon double bond is there. So, ozonolysis is basically a cleavage reaction in which two molecules are formed, or cleavage of carbon, complete cleavage of carbon-carbon double bond takes place. So here carbon-carbon double bond is there, and this carbon-carbon double bond completely cleaved, and formation of two different kind of molecule is there. Different molecules, or maybe the same molecules, preparation takes place. So it is completely cleavage reaction. So ozonolysis is the reaction in which carbon-carbon double bond is completely cleaved and yields two different products there. So two different products are yield here. Product yield obtained here. Now in this case, the classical reagent for this ozonolysis is ozone. O3 is the classical reagent for this. It is a two-step reaction. Ozonolysis is a two-step reaction in which first step is formation of ozonide. Ozonide formation is the first step. We will go in detail for ozonide formation and the breaking of ozone, and second is the breaking of ozone or hydrolysis of this ozonide. Breaking of ozone by using some reducing agent like zinc. Reducing agent like zinc is used to break this ozonide form, and we get the cleavage product or yield of the cleavage product. So this is about ozonide. How the process of ozonolysis takes place? The process of ozonolysis. For this process, see here we have passed the ozone gas. Ozone gas must be passed through the solution of alkene in some inert solvent such as CCl4. Then we obtain inert solvent. Then we obtain ozonide. When the evaporation of this inert solvent takes place, the evaporation of this solvent took place, then we obtain ozonide in oily form. In oily form, we obtain the ozonide, leaving behind the oily form, that is ozonide. And this ozonide obtained in the first step is broken by hydrolysis by using some reducing agent, and we get the cleavage product. So this is total ozonolysis process. We have to see this process in detail. We have to see the mechanism of this process in detail. So see, I am repeating once again. Ozonolysis. Ozonolysis is the cleavage reaction in which carbon-carbon double bond is completely cleaved. In previous reaction, what we have seen, we have seen that the most of the cases, one double bond is removed and two atoms or two molecules are added across the carbon-carbon double bond, but not complete cleavage. But in this reaction, there is a complete cleavage of the carbon-carbon double bond. This complete cleavage of carbon-carbon double bond to yield two molecules. So this is ozonolysis reaction. This is two-step reaction in which first step is ozonide formation and second step breaking of this ozonide by some reducing agent like zinc. So in the process we pass ozone gas into the solution of alkene in presence of some inert solvent. Then we obtain ozonide. When evaporation of solvent took place, then remaining part is the oily part, which is ozonide. That ozonide is broken by hydrolysis because it is generally explosive product, and this explosive product we add the water in presence of zinc reducing agent, then the reaction stop at this stage and we get the cleavage product. Further oxidation is prevented in this reaction, so we obtain cleavage product. So see in detail the mechanism how the reaction takes place. So we have to see the detailed mechanism of this ozonolysis. So in the mechanism, our important reagent is that we have used reagent, that is ozone. Okay, so let's see the mechanism, and in the mechanism we have to see the resonating structure of ozone. See the ozone is O3. O3 is the ozone. Now O3, in this O3 ozone structure is represented in this way: oxygen, another oxygen, and this oxygen. These oxygens are bonded in this way, and here O11, it has complete valency, so it gets plus charge, it gets negative charge. Okay, so this is structure of ozone. Ozone is a dipolar molecule where two poles are separated, and in the resonating structure, see this negative charge is delocalized here, so we get structure here O with this negative charge, oxygen, and double bond shifted here with this positive charge here, and oxygen is here, it is completely saturated, valency is completed here. Now again see another resonating structure of this ozone. In another resonating structure, see here this bond shifted on this positive charge, so that this positive charge gets neutralized. When this positive charge gets neutralized, the another oxygen gets positive charge, so structure becomes O negative. This positive charge on this oxygen gets neutralized, and this O gets positive charge. So now this is 1,3 dipolar compound. 1,3 dipolar compound octet. There may be, this structure may be represented in this way: oxygen, this oxygen, this oxygen gets positive charge, this one gets negative charge. So all these are canonical forms or resonating structure of ozone molecule. Now what is our observation? In the observation of the resonating structure of ozone, it is clear that we can get information that every oxygen atom gets positive charge. Every oxygen atom is electrophilic. So every atom is electrophilic. So there is possibility of every oxygen atom is electrophilic. See here, this central oxygen atom having positive charge. Here right oxygen atom having positive charge. This left oxygen atom having positive charge. So every atom of the ozone having electrophilic character, and that's why electrophilic addition to carbon-carbon double bond is possible. And here 1,3 dipolar compound, so 1,3 dipolar addition is possible in case of this ozonolysis, in case of this ozone and carbon-carbon double bond. Now see the actual ozonide formation. So if we see the formation of ozonide, then it is a several step process, not a single step process, in which this ozonide formation, first this carbon-carbon double bond react with ozone, to form monoozonide, and this monoozonide, the breaking of this monoozonide takes place, breaking into two molecules, and these two molecules recombine in another way, to form ozonide. So this is the journey of ozonide formation. carbon-carbon double bond react with ozone to form molozonide, and breaking of molozonide into two molecules. These two molecules recombine in another way, alternate way to form ozonide. Let's see the actual reaction. How this ozonide formation takes place, molozonide formation takes place. See here, we have taken example. So addition of ozone here. Now we know that 1,3 dipolar structure of ozone is possible. So take here 1,3 dipolar structure, O, here oxygen, negatively charged and positively charged. Okay, we have taken that structure, 1,3 dipolar compound. Now this negatively charged compound, this negatively charged electron density attacks on the carbon, due to which this carbon-carbon double bond electron density shifted here. Okay, it shifted here, so we get the structure CH3, here C, this CH3, this H, and now the attachment of this oxygen, and formation of this type of structure. This is a molozonide. Formation of molozonide. So this is molozonide formation takes place. Now in the molozonide formation, this is very unstable structure. Molozonide cannot be separated. So it's an unstable structure. Within a fraction of a second, this structure changes to ozonide. How this structure changes? In this structure, the molozonide formation, this structure changes in this way. The pair of electron on this oxygen gets attacked here. So formation of double bond here, and breaking of this bond, and due to which this bond broken and negative charge is on the oxygen. So molozonide is broken into two molecules. See how two molecules obtained. See here, CH3, C, here H, double bond O, here double bond formation, O gets positive charge due to electron shifting, and O, this another O, bond between these two oxygen broken, and O gets negative charge. Now here this bond between carbon and carbon broken, so C double bond O, and here remaining groups are there, so CH and this CH3. We have just rotated this carbon oxygen double bond, so we rotated here C double bond O. Look here again, this carbon carbon double bond, here addition of ozone molecule takes place. So this addition of ozone, negative charge attacks here, and electron density of carbon carbon double bond shifted here on this oxygen, so we get molozonide formation, this molozonide. Now breaking of this molozonide, because it is an unstable structure, three oxygens are here, unstable structure, and due to unstable structure, this molozonide undergoes breaking to form two molecules. These two molecules are formed here. These are react or recombine in another way. So here the double pair of electron on this carbon oxygen shifted here, and breaking of this carbon carbon bond takes place, and again oxygen oxygen bond takes place, and we get these two molecules. Now these two molecules recombine in alternate ways. So this negative charge attacks here on this carbonyl, and the carbon oxygen bond gets shifted here, and again the electron density shifted on this positive charge, and neutralization of the positive charge. So neutralization, see which type of product obtained, C, which gets CH3, this hydrogen here. Now carbon oxygen bond formation takes place here. Here another carbon oxygen single bond, CH3, here H, and this oxygen, this is another oxygen. So this is actual ozonide formation takes place. This is ozonide. This is hazardous compound, so some precautions we have to take. So it is seldom isolated. If very needed, then and then this ozonide will get isolated, otherwise this ozonide will not get isolated because it is a hazardous compound, it is explosive compound, so ozonide not get separated always. So it is a hazardous compound, so we have to take precaution that we do not separate these compounds. It takes place in vitro, reaction takes place in vitro, and this ozonide obtained which hydrolyzed or broken by using some reagent. So we have taken in the next step, second step, this ozonide broken by using hydrolysis in presence of zinc. See how breaking of ozonide took place. See, zinc is here. Now this bond is undergoes breaking. This is not much stable structure, but it has a stability that it occurs as an intermediate. So this bond undergoes breaking. Due to this bond shifted here, breaking, and now due to this bond breaking, and which shifted towards zinc. So these two bonds of this oxygen gets removed and it attached to zinc. So ZnO formation plus these two remaining molecules CH3C, here carbon oxygen double bond. So first structure is CH3CH double bond O plus on this side CH3C double bond O H. So we obtain these two aldehyde molecules. Here whether aldehyde formation, whether the ketone formation, that depends on whether the structure containing substituent. Structure of alkene decides which compounds that will form as a degradation product. So degradation product here, aldehydes, two aldehydes obtained, sometimes two ketones may obtain, sometimes one aldehyde, one ketone may be obtained. So this is all about the mechanism of the ozonide formation, mechanism of ozonolysis. In the ozonolysis process, these two steps are there. First step is formation of ozonide. It is a slow step and rate determining step. Second step is the breaking of this ozonide to form, to yield either aldehyde or ketones in the reaction. So this is about the mechanism. Now we have to see some examples of ozonolysis. See how the product depends on the structure of alkene. Product of ozonolysis depend on the structure of alkene. See some examples here. Examples of ozonolysis. So product of ozonolysis. See, we have taken this compound CH3 double bond CH. Well, first step is the ozonolysis where monoozonide formation takes place. Second step is the hydrolysis in presence of reducing agent like zinc. So in the first step, ozonide formation, and finally the product obtained is CH3C double bond O CH3 plus C double bond O H. So here we obtain formaldehyde as one of the product. See the second example. CH3 CH3H, and same ozonolysis process is there. First step ozonide formation, second hydrolysis of ozonide. So hydrolysis of ozonide will give the product, that is CH3 double bond O plus C